Determine equation of the graph. So we have a bell kind of a graph, but it looks like a sinusoidal function also. I would like you to write a sinusoidal function or a cosine function for the given graph. Treat it as a test problem. Stop the video and do your solution. And then you can watch the video to see my suggestions. So whenever we want to represent a graph as a sinusoidal function, it is good to start with the very basic and general equation. The most general equation which can incorporate such situations is f of x equals to a times f of k x minus p plus q, where a is the amplitude, k is a horizontal stretch or compression, and it also tells us number of waves in 0 to 2 pi or in a period of 2 pi. P is the phase shift. It tells us how much the wave has shifted from the y-axis. And Q is a vertical shift. It tells us how much the axis of symmetry has shifted from x-axis, correct? So these are the basic definitions of the coefficients associated with the general equation for a sinusoidal function. Now, we can find A by writing A as equal to maximum value minus minimum value divided by 2. Maximum of the graph, which is 2 in this case, and minimum in this graph is 0. So we can say, well, A is 2 minus 0 divided by 2, which is 1. So that is A. In this case we are using Q. Q is transformation, vertical. So Q is the average value. Average is average of maximum and minimum. So we can find Q as equals to maximum plus minimum divided by 2. In this case, 2 and 0 are maximum and minimum values. We can say 2 plus 0 divided by 2, which gives us 1. So we got values of Q and A. Now, how to figure out the value of K? So K is kind of how many waves are there in 0 to 2 pi. It looks like a quarter of a wave, right? Okay, the other way is to figure out the time period. So, it's just like the half wave, not quarter, because that is the line. You'll see the half wave, yeah. So, K is number of waves in 0 to 2 pi. So, if you say 0 to 2 pi, in this case, that seems to be half of the wave. Half is on this side, correct? So, half between 0 to 2 pi. Another way to find the value of K is by doing K is related to time period. It is 2 pi by time period t. Now time period is time for one full cycle. So we can see here one full cycle is from minus 2 pi to plus 2 pi, which is 4. So we can say, well, K is 2 pi divided by 4 pi, which gives us a value of half. So which is half. So K is half. Correct. As expected, K is half. Now to again check our function, let's draw the lines which we have, especially the axis of symmetry. Q equals to 1, which is here. So let me draw the line Q equals to 1. So you can see from here that amplitude is how much above this line the wave goes maximum. So it goes from 1 to 2, value of 1, that is correct. And 1 down, perfect. That is why it is axis of symmetry. So A is correct for us. Second is number of waves in a period of 2 pi. This is half the wave, right? So K is also correct for us. And D, of course, is correct. Now, since we have all this, let's figure out the phase shift. Now phase, it starts with maximum. That means we can straight away write cosine function without any phase shift. Correct? So let me first summarize the values which we have already got. First, A equals to 1, Then we have q equals to 1 and k equals to half. And phase shift, if we take cos, then there is no phase shift. So we say p equals to 0 for cos. So we'll write this function as a cosine function. We say f of x is equals to a is 1. Okay, so no need to write 1. Cos of k is half. So let's write bracket now. Half x. Now it starts from maximum, so p is 0. And q is, it moved 1 unit up. Plus 1, right? If you have to write this as a sine function, then you see sine function actually starts from here. So how many units is this from the axis, y-axis? So let's see the divisions. So we have how many divisions? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 or 12. So maybe 12. So we will, now again we'll count, okay? So it seems to be starting from here. Let's count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, maybe 12. I'm not sure. Normally we divide it into to even parts, right? So it's like kind of ending here to here. So we'll assume 12 for the time being. So each division is 2 pi by 12. 2 pi by 12 gives us pi by 6, correct? So each division is pi by 6. So anyway, this is half of 2 pi, so it is pi units to the left. So for sine wave starts pi units to the left. Let me check. 1, 2, 3, 4, 5, 6. That is correct. So pi by 6 is correct. Now, so you can write this function as a sine function also. So in sine function, phase shift is there because the wave starts pi units before, right? So we say it is sine of half is the k value, x plus pi plus 1. So this way you can write this as a sine function, right? Remember, sometimes the students take this point, but this is not the right starting point for a sine function. Sine function starts like this, right? It has to be rising. And here it is falling down. So that is not the point. This is the right point, okay? I hope by now you have mastered writing equations for functions which look like sinusoidal functions. All the best, and I hope you get good marks. Thank you.